Hi, welcome to the tutorial on improving upon the mean regression model. By the end of this topic, you will be able to suggest and implement different ways to improve mean regression model. Getting back to our example, we calculated the average of all the runs scored by Virat Kohli in his entire career. But it is possible that he might have different performance with respect to different teams he's playing against. So, a better prediction would be to calculate his average score with respect to the next opponent team. Similarly, in our dataset also, it is possible that houses with different overall grade have different sale price, and a better prediction would be to calculate average sale price with respect to the overall grade of the house. So let's try to calculate the average sale price with respect to the overall grade. We are going to use the pivot table function to find the mean of the sale price with respect to the overall grade of the house. Here, you may notice that while writing the syntax for pivot table function, we are not specifying how we want the data to be aggregated, and by default, it gives us the mean aggression. In the result, we can clearly see that we have obtained 10 different mean values of the sale price, one for each unique value of overall grade. So, houses with overall grade as 1 have an average sale price of 142k. Houses with overall grade 3 have an average sale price of 205k, and so on. You may notice that in general, while the average sale price increases with grade, however, the average sale price for grade 2 is approximately 1.13 million, which is much higher than any other grade. This could be due to the presence of some high value data points which are equal to or close to the upper limit. Note that you can use any categorical variable or even a combination of them to calculate the mean of the sale price. So feel free to be creative and calculate mean depending upon other characteristics as well. Now, let's store this grade-wise mean to a new column, grade mean, in our dataset. For this, we start by declaring a column grade mean and initialize its value to 0. Then I am filling the rows in grade mean column with corresponding value of mean sale price as per the overall grade of the row. We have seen the code structure before when we studied advanced pandas function. So in case you are having trouble understanding it, now would be a good time to revise that topic. Now, on using the dot head function, we can clearly see the new grade mean values. But how does this model compare to the overall mean prediction model we built previously? Let's visualize them together to see how they compare with each other. So first, we focus on plotting the actual data points grade-wise. Then, we plot the respective grade-wise mean. Once we complete plotting the grade-wise mean, we also plot the overall mean to compare it against the grade-wise mean. Starting with the grade-wise plots, we are going to plot the house price with respect to the grade-wise list. We will be superimposing 10 plots in a single plot, where each plot will represent the houses with different grades. So we define a loop where the variable I takes a value between 1 and 10. Inside this loop, we first define the x-axis as a list named points for overall grade equal to 1. Once we define the x-axis, we are going to plot the first scatter plot corresponding to overall grade equal to 1. For x-axis, we pass the points as the parameter and first row from the superlist grade-wise list. As we print the actual data points grade-wise, we will also plot the grade-wise mean price as a pink line. Again, we use the variable points to define our x-axis, and in this case, our y-axis is the mean price for that grade of house. Right after plotting this function, we update the value of z, as we will need to define new values of x-axis for the next plot. This loop runs 10 times and plots the sale price for every overall grade. Next, we are going to plot the overall mean in the same plot. For this, we simply use the pre-computed z value to use the x-axis, and then we use the data mean sales for the y-axis. One thing you should note is that in the last line, we are using lock equals to 4 in the plt.legend function. Here, we are specifying the position of displaying the labels at bottom right of the plot. So let's run this cell and look at the results. In the graph above, we have visualized both our models by plotting their prediction with respect to actuals. You may also see that in the second model, which is mean sale price with respect to overall grade, is represented by the pink line, and the predictions are closer to actuals as compared to the first model represented by the red line. In case you find this visualization difficult to understand, do not worry. There is another very useful way to visualize models and compare it with other models, which is by plotting the residual plot. Let's discuss the residual plot in the next tutorial.